So now we're going to talk about those transformations that we've been alluding to. So when I write these, B and C are constants. Okay, so they're real numbers. But B has to be greater than 0 and B can't be 1. That still holds. Okay, so we're looking at, here's the basic function, f of x equals b to the x. And now we're going to do stuff to it to do transformations. Okay, so first we could have a vertical shift. That's going to look like if you had a function b to the x, and then you added some number. That's going to shift up. It's going to just take the whole graph and shift it up, including the asymptote. Okay, let's say you had b of x, but you subtracted some number. Well, that's going to shift down, including the asymptote. Okay, the whole thing just shifts down. A horizontal shift. A horizontal shift, well, if you have b to the x minus c. Now, you've got to look at the difference here. Here, the c is not in the exponent, but in this one I just wrote, the c is in the exponent. So it's really hard to tell you if you're really careful the way you write it. That is going to shift, though, to the right, c units. And if it were g of x equals b to the x plus c. Okay, I'm trying to write it little so it looks like it's up in the exponent there, but then that's going to shift left. It won't change the asymptote because the asymptote's at 0. It's horizontal, so that's not going to shift. Okay, a reflection. Well, if g of x, we've seen this before, is b to the negative x, that reflects about the y-axis. That one we saw. We talked about having a fraction for a base, and that's what happened. But if you have g of x, and you put the negative sign in front, and then b to the x, that doesn't make b negative before you do the exponent. You have to think about the order of operations. We talked about that in our examples of, well, is this a function, an exponential function or not? This is because you're doing the exponent first, and then you're doing the opposite of it, okay? So your base is positive. That still holds. But anyway, this is going to reflect, probably figured that out already, about the x-axis. So it's going to flip it upside down. Okay, let's talk about vertical, stretch, or shrink. So if it's vertical, then it's c b to the x, okay? If c is greater than 1, then it's a stretch. And if c is less than 1, and I'll say greater than 0, we're assuming, c could be negative, but that would make it reflect. Okay. And if c is between 0 and 1, then that's going to make it shrink. And then a horizontal stretch or shrink, that's when we have b, and the c is up here by the x, so you're multiplying x by c first, then you're applying the exponent idea. If c is greater than 1, that's going to be a horizontal shrink. And if c is between 0 and 1, again, it could be negative, but that will have to do with the reflection. But if c is between 0 and 1, it's going to be a stretch. I don't know that we'll see a lot of horizontal stretching and shrinking, but we might. Okay, so let's do an example. It says use the graph of f of x equals 3 to the x. Okay, so what I like to do is just do a quick little table of values, x, f of x, and think about what we're putting in. -1, 0, 1, 2. And I mean quick, So I get a 1/3, I get a 1, a 3, and a 9. That's my original function. I'm going to put it in red. I don't know, I guess I could dot it. Put it in black. They say not to use red. All right. Let's see, -1, 1/3 is going to be down there someplace. We know it's doing something like that, and then something like that. So the original function, f of x, before we do a transformation, is looking something like that. Now we're going to look at g of x. Now you could do a table of values, but it's easier to identify the transformation. Okay, so it's the 1, and the 1 is in the exponent, okay? So because it's in the exponent, this is going to be horizontal shift. I think your book calls them translations instead of shift, but that's okay. All right, it's a horizontal shift, and it's going to be 1 to the, anybody know? Left. Okay, so it's going to shift the whole thing 1 to the left. All right, so I take all my points and I move them over 1. Like it's going to be hard to see those. But there they are. And it kind of looks like that. The graphs are kind of running into each other, but anyway. All right, that was a horizontal shift.